Hello, and welcome to your week 12 lecture video. This will be your final lecture video for the semester. Just a reminder, you have, well, before we get into the reminder, I guess, this is all going to map to Lab 8, your theory that you need for Lab 8. But as a reminder, you have Assignment 2, which you should be working on, and you should do that before you do Lab 8. Assignment 2 is due the end of next week, which is week 13. And I'm going to include a review for your final in this week's video at the end, so we don't have a lecture next week. Which hopefully sounds good. You just got some stuff to work on. So this week we're looking at DHCP, or Dynamic Host Control Protocol, which you should be a little bit familiar with, because I believe you should have done something with this in your other courses. At least we used to when I was a student. So we're going to learn about how to configure a DHCP server for your network and why you want to do this. This is a common thing. We configure DHCP servers for our network to dynamically allocate IP addresses to other devices on the network, so when they boot up you don't have to give them all a static IP, right? Generally you reserve static IPs, which we learned about a couple weeks ago. You reserve that for things like servers and routers and things that, printers, things that you want to be able to access them over the network, and you want to know reliably where they are. But for every single workstation in your organization, they're going to pull from a DHCP server, right? Just like your home network, whether you realize this or not. Your home router has a DHCP service running on it that assigns IP addresses out to the devices on your network. So we mentioned what it stands for, right? It does exactly what it says on the slides. It lets, and I just kind of touched on this, right? It lets you auto-assign IPv4 addresses to devices so they can be accessible and access other resources on the network. As part of that automatic configuration, not only do they get an IP address and a subnet mask, it can pass along the default gateway, the IP addresses for DNS servers, because if they don't have one of those, they can't resolve anything, right? And other information too, like if they're part of a domain. DHCP servers can pass that information along to the devices. It's a useful thing. So this is done usually from a centralized location, right? One of the things we like as system administrators is having a single centralized point of management. Not a single point of failure though, right? You can have a couple DHCP servers, which will save you if one goes down, and make your configuration a bit more efficient. But the nice thing about DHCP is not only does it simplify assigning IP addresses to devices on your network that you don't want static ones, it does also keep track as to which devices are given out and to which devices they have. So this prevents two devices from having the same address, which could happen, right? It's a useful thing. It's also useful for mobile devices. Bring your own device has been a rising trend in the workplace for a number of years now. So you could be bringing your own laptop or a tablet or a phone or all of the above into an office, and it would be kind of a pain in the ass to reconfigure going from one organization to another. DHCP just takes care of it and gives you an IP address at either location, right? So how does it work? Well, when the device connects to the network, it sends out a DHCP broadcast, a DHCP Discover packet broadcast. And this goes out to every single device on the physical network. And ignored by everybody except for the DHCP server. The server responds offering an IP address, the client then responds and accepts it, and there's an acknowledgement sent. In fact, this can be remembered by the acronym DORA: Discover, Offer, Request. That's the what I meant to say. The that third packet is. See, I got to think about this thing. That third packet is a request, not a response. So discover, offer, request, acknowledgement. DORA, not just the Explorer. So in Lab 8, you're going to set up a DHCP server, and you're going to configure the rest of your network, your other two virtual machines, to act as DHCP clients, which is why you shouldn't do this before you finish assignment 1, because it's going to break your network. Which, I mean, you could reconfigure your network, but why? Why? So, IP address allocation. Oh, we're going to get into DORA in a second on the next slide. That's what we call when an address has been assigned to a device. So the server has a pool of addresses, and it assigns one that's free. It could be done in a couple different ways. Automatic. This is known as a DHCP reservation. So the server will assign an IP address to a specific MAC address, and it's associated, right? So every time that device comes online, you, the admin, usually have to go in and configure this, right? But every time that device comes online, it's going to get that IP address guaranteed. In fact, you could configure this in your own home network if you have a wireless printer, or maybe you've got a desktop somewhere that's also acting as a server, and you want it to always have that static IP address. You don't have to assign it as a static IP address in a small network. You could just set a reservation in your DHCP server, and it gives you a centralized place of administering all this stuff. So that's a good thing. The other way it could be done is dynamically. The server assigns an IP address to a MAC address, and it's called a lease. So the client leases that address for the duration that is configured by the server, right? It can be renewed infinitely, but the client has to initialize that renew. If the client doesn't request it, then the IP address is added back to the pool and removed from the client. So there's DORA, right? Discover, Offer, Request, Acknowledgement. So the Discover packet is a broadcast packet. The Offer, Request, and Acknowledgement are all unicast because they know how to get there now, right? But that Discover packet works on the same subnet. These are dropped by a router unless the router has been configured as a DHCP relay agent. So there we go, DORA, right? Client comes online, says, hey, I need an IP. Server says, hey, do you want this IP? Client formally requests that IP. The server acknowledges, yep, you got that IP, and here's the terms and conditions, right? The lease duration and stuff like that, which you're going to set in Lab 8. Now, depending on what Linux distribution you're using, in our case we're using CentOS, right? But depending on which Linux distribution you're using, it could be installed by default, it could not. And you may not know. So how do you check? Well, you could use yuminfo or rpm-qa, right? DHCP. It'll tell you if it's installed or not. And if it isn't, you just install it using yum. Sudo yum-y install DHCP. Or you can stick the -y at the end of the line like they did on the slide. Doesn't matter where that -y is on the line as long as it's there, and that will auto-assume yes. It's a useful thing. The main configuration file is in etc, right? Of course, because that's where everything goes. DHCP, and it's dhcpd for daemon.conf. And this contains global settings that apply to the entire network. It also contains subnet declarations that only apply to a particular subnet. Because a common way that you implement DHCP on a network is you have one or a couple servers that deal with the whole domain, and you're going to have clients and other subnets. How are they going to get IP addresses? Well, you set up a DHCP relay agent that say, hey, on that particular router that's going to drop those broadcast packets, right? That says, hey, when you receive a DHCP packet, send it to the server. The server will know how to get back, right? And then you configure all your pools on that one or that cluster of servers. It's a handy way of doing things. Like everything else, right? Any other service that you configure in Linux, when you change the configuration file, you have to restart the service. So you do that with sudo systemctl restart dhcpd. That'll restart the service. And then you usually want to, I always anyway, issue a status, sudo systemctl status dhcpd, to confirm that it's running. Some common global options that you can and will want to assign are your IP address range, right? Because otherwise the pool doesn't know the start and the end address, so that's an important thing. You can set the lease time, so you can set the default and the maximum lease time for clients. Router, so that's your default gateway. It says it's optional, but it's kind of not really. You need that. Otherwise, your client isn't going to get a default gateway, and it's not going to be able to get back. Domain name and DNS servers, also somewhat optional. If you want to assign a domain suffix and the IP addresses for the DNS servers to the client, which of course they're going to need DNS servers, right? Because they need to be able to resolve DNS and get out on the internet. Otherwise, what are you doing? So lease duration refers to the amount of time that the IP address can have the device. And once that time passes, one of two things happens. Either the client device will, before it expires, ask to renew it, which will reset that lease to the full length. This is going to happen if the client's still online, right? It's going to say, hey, look, my IP address is going to expire. I better contact the server and see if I can have this a bit longer. If no renewal is requested, then they're not online, they're not using it anymore, so it's disassociated with the MAC address, and it's returned back to the pool of available addresses that can be assigned out later. This is a very efficient thing, right? This is how we don't run out of IP addresses. Lease time, there's two ways you can set this. The default lease time, so if the client doesn't specify the duration during the four-way handshake, it's a four-way handshake with DHCP, then this is the amount of time it has the address for. And the maximum lease time, again, if the client doesn't specify, this is the maximum amount of time the address can be reserved for, and this is written in seconds. Now, for troubleshooting, when something's going wrong with DHCP, usually when you're starting a service and it fails to start, usually means there's a typo in that file somewhere, in that configuration file, or if it's a service like DNS that has more than one configuration file, it could be in a couple different places. So the easiest way to check for it, two terminals side by side, try to run or restart the service, but before you do that, in the other service, or other terminal, do a sudo tail-f varlog messages. And like 99% of the time, that'll tell you what's going on. It might even say, syntax error on line 32 or whatever. And typos are one of the most common issues you're going to encounter when you're configuring servers and configuring services. Little things can be a huge hassle. But there's two other things that you might want to check when you're troubleshooting, because maybe the service is starting, but your servers aren't, or your clients aren't getting IP addresses, or they're not able to get outside the network because you left out the default gateway or something like that, right? So you could check var lib dhcpd dhcpd.leases. So that's a file on the server. It has a record of all the leased addresses. And if the service has been restarted, it reads that file to know what's been assigned. So if you need to see what's been assigned where, you can check there. Another place you can check is in var libdh client, and that's on the client side of things. That's where the client stores its record of leases. So this could be a useful thing, right? Now, there's 3 ways on the client to get it to run the 4-way handshake and request a new IP from DHCP. Because it might fail the first time, right? Maybe the server wasn't up, and it's going to fail because you forgot to bring the server up first. So you bring the server up, and then what do? Well, you could reboot the system. And that's the least I'm trying to reword what I was going to say. Least is not the word I wanted there. Yeah, least. That's the least desirable option, because that takes time. You could just bring the interface down and back up again, right? The one you're trying to pull an IP on. And when you bring it back up, it's going to send a broadcast. So that's one way. You could also run the DH client command. So that's even less work. It's 1 command, not 2. Make sure you set your IPs or your virtual machines to request an IP from DHCP, just like it tells you in the lab, because we did a static configuration before, and I mentioned this, right? That's why you want to finish lab assignment 2 first before you do this one. Honestly, this is a fast lab. There's no reason you shouldn't do this quick, or shouldn't be able to do this quick. That's the reason why it's going to be like a half-hour video tops. And there's a third type of address that you can get through DHCP as well that we didn't talk about. Fixed addressing, or reservations, right? So what were we talking about before? Because I swear I talked about reservations. So that's where you're giving an IP a particular address with that device. So it functions kind of like you did with Lab 7 with static networks, but you're doing it from the DHCP service, and every time that the device with that MAC address comes online, it gets that IP address. Anyway, fixed addressing. Yeah, it's a DHCP reservation. Wording's funny on that slide. That's it about DHCP. It's a pretty easy lab. Honestly, it's probably one of the easiest labs, which is nice to have at the end of the course. You're going to want to finish assignment 2 before you start Lab 8, because Lab 8 is going to break some stuff. I mean, it's not the end of the world. You can just undo parts of Lab 8, but just finish assignment 2 first, right? And if it comes down to the wire, you know, end of next week, when everything's due, because you've got till the end of week 13 to get the labs and assignment in, right? Focus on assignment 2 because it's worth 15% of your grade. Also, if you don't submit assignment 2, you can't pass the course. If you don't submit Lab 8, though, it's only 1.5%, and you can totally pass the course if you don't submit Lab 8. So it's not the end of the world. So that's your DHCP lecture out of the way. I will see you in this week for the lab. However, let's talk about your test, because you're probably going to want to start studying. That's not your test. That's web design stuff. There's your test. So test 2 is 30 questions. It's going to be the same format as test 1, or same format, the same delivery. So we're going to do it in the in-person class in week 14, which means you're not going to have any online lecture in week 14. Isn't that awesome? You're actually not going to have any online lecture next week either, because you got a ton of stuff to work on. So there's 15 multiple choice questions, and these are all general knowledge. 10 short answers that are focused on commands. So it'll ask you, what's the command to start the DHCP service daemon, right? Or stop, or show me that it's running, or something like that. And 5 long answer or troubleshooting questions. So these are going to describe a scenario and ask you for steps to resolve the problem. What do you think the problem is, and how would you narrow down the focus and maybe resolve it, right? You don't have to get the correct or identify the correct problem. It's walking me through the steps on how to figure out what the problem is. That's the important thing here, right? There's only 2 Python questions on the whole thing. One of them's in the troubleshooting, and it's something to the effect of you've written a Python script, but it's not running. List some steps as to what the cause of the problem might be and how you might solve it, right? There's also one in, I think it's the multiple choice, where it asks you for the shebang line of a Python script. That's it. 30 questions. Half of them are multiple choice, 10 short answer, 5 long answer. That's your entire final exam. It's based more so on the stuff we've done since the midterm, so labs 5 through 8. There's a tiny bit that's going to pull from the first half of the course, but it's mainly the second half, right? So that's it. 20-minute video. Awesome. Take care. Be safe. I will see you in this week's class. Good luck with everything. Bye for now.